ಎಲ್ಲರಿಗೂ ಬೆಳಗಿನ ಶುಭೋದಯ. ಹಿರಿಯರಿಗೆ, ಇಲ್ಲಿ ಬಂದಿರುವ ಬಂಧು ಮಿತ್ರರಿಗೆ, ಒಂದು ಏನು ಅಂತ ಸ್ವಲ್ಪ ಟೆಕ್ನಿಕಲ್ ಆಗಿರೋದ್ರಿಂದ ಒಂದಷ್ಟು ಇಂಗ್ಲೀಷ್ನ ಬಳಕೆ ಮಾಡ್ತೀನಿ. ಸೊ ಅದು ನಿಮ್ಮ ಅನುಮತಿಯಿಂದ. ಯಾಕಂದರೆ ಇವತ್ತಿನ ಟೈಟಲ್ ಇರೋದೇ AI ಪವರ್ಡ್ ಅಪ್ರೋಚಸ್ ಟು ಏನ್ಷಿಯಂಟ್ ಸ್ಕ್ರಿಪ್ಟ್ ಪ್ರೊಸೆಸಿಂಗ್, ಪ್ರಾಚೀನ ಲಿಪಿಗಳ ಸಂಸ್ಕರಣೆ, AI ವಿಧಾನಗಳು. ಸೊ ಒಂದಷ್ಟು ಟೆಕ್ನಿಕಲ್ ಮಾಹಿತಿ ಇರೋದ್ರಿಂದ ಒಂದಷ್ಟು ಇಂಗ್ಲೀಷ್ನ ಬಳಕೆ ಮಾಡಲಿಕ್ಕೆ ನಿಮ್ಮೆಲ್ಲರ ಅನುಮತಿಯಿಂದ ಐ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಮೈ ಸ್ಪೀಚ್ ವಿತ್ ಇಂಗ್ಲೀಷ್. ಸೊ ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. And first of all, I would thank Mythic Society for providing such an opportunity. Thank you so much. So let's assume there is a case. We are all very fascinated visiting historical places. And we see some scripts being inscribed on the stones or maybe on the walls of a temple. And we try to read it, but unfortunately, as a common layman, it will be very difficult for most of them to understand what it is, which era the inscription is, or it might be very difficult to understand who is this who has been inscribed on those things. Let us assume if there is an application, a mobile kind of an application, if I capture something on the mobile phone, and if that mobile phone or my application helps me to understand what is that script, especially to recognize what is that character, and whether it can be translated so that everybody can understand it. So that will be a most efficient way to understand the history. So today we are in the era to come up with such kind of an application with the help of an artificial intelligence. Hope right now such kind of applications are not there. Maybe in the future, because of artificial intelligence techniques, whatever that we have, probably there is a lot of scope and opportunity for us to come up with such kind of an application. So if you look at the title here, what is the object of script processing? Script processing doesn't only involve in preserving the ancient documents. Script processing has to be translated so that it can even reach the common layman. Until unless if the people doesn't understand and have the access to read those ancient scripts, preservation will remain as a preservation. It will not remain as an accessing element. So it has to become, the script processing has to become a knowledge processing document. So with regards to that, I'll continue my talk. So we all know that there are different forms of ancient scripts being inscribed, maybe on the stones, maybe on the copper plate, maybe on bark paper, or even the copper plates or the metal coins, and the conventional paper, whatever that we see today, right? So the text being inscribed on these different types of forms has to be processed, or it has to be preserved. So though we have a lot of technologies, but there are a lot of challenges which are involved in this script processing, as pretty much all the historians know about this, how they can preserve it, what would be the challenges. When it comes to the preservation, the first thing is the aging factor of the aging of all the documents, that whatever that we see here, where the documents which are being preserved might get degraded because of the environmental factors, because of probably like some chemical reaction, or maybe it's a negligence of a human not preserving the document proper way, right? So we have two different conventional methods to preserve the ancient documents. But as I said, today's talk is not just about the preservation, it is also about the processing the script so that the processed script can be reached to all common laymen. So as we know that the methods at which we use to preserve the document is the physical method. So where we have to, based on the kind of the document, you have to see, I mean, all the historians know about the first part. So I would be talking about the second part, digitization method, where the ancient scripts, whatever that is being available, we can make use of a high resolution scanners to preserve it. That's one technology which we have. And then 3D scanners are available in the market. With the help of a 3D scanners, we can also preserve the document. So I should actually congratulate Uday Kumar sir and his team, because they are into this process of using a 3D scanners and preserving the ancient documents, and being with the support of the Mythic Society. Thank you, sir. We need your help for processing further. So it's a beautiful work. It's not a small work to preserve more than 1,700 plus the inscriptions that are available. I think it is already available even in the website. Anybody can have the access to it. And then we also have a multispectral imaging techniques which will help us for recognizing the low quality images, and it can be preserved in it. But despite of all the digitization methods that we have, that is not actually sufficient for processing the script. As we know that the script would have been in a degraded document. It might be a smudged, or there might be some characters which are missing due to the aging factor, or some of the links would have been mixed. Some of the characters which has been inscribed maybe on the palm leaf or maybe on the sword would have been missed. Now it's a work of a technology where it has to be restored. The missing links has to be restored. So for that we have a lot of approaches. So let me discuss with the fundamental approaches which we use for script processing. The first and foremost thing is image acquisition. As I said, its image acquisition is a stage of collecting the data from the various resources. Maybe be it from a scanners, be it from a good SLR cameras, be it even your mobile phones, be it 3D scanners. So first of all, we have to acquire the data as much as possible. So this is a very, very, very important stage before we start our script processing. Without a proper documents available, so this is always a challenging factor. So once we have a sufficient amount of scripts, as I said, there would be a possibility of the documents getting degraded. Now, from the degraded documents, we have to extract the scripts. We have to take out the text, generally what we call it as the character recognition, which are already being placed, optical, we call it as an optical character recognition. So we have several techniques for recognizing the characters. Before we recognize those characters, it's very, very important to pre-process those images. Without we don't pre-process the images, character recognition is always a challenging task. So let me bring up what are the different, the first stage what I said is pre-processing stage. In the pre-processing stage, so the first thing that what we do is remove unwanted pixels that are there in the scripts. Unwanted pixels in the sense, as I said, the unwanted shading should be there, the smudges should be there, or the image is not so clear enough. We have to restore the pixel so that it is visible properly. So we use a pre-processing. I'll get into the details of a pre-processing technique with AI methods. And then it's very important, then we have to convert that image into a binarized image. I'll give you an example what exactly a binarized image is. And once this image binarization is done, we have to segment, because if you take a palm leaf, you can see a lot of scripts on it, or the letters on it, which are being written, and where you have to extract every word, every character from it. So that's a process called as a segmentation. So we have to undergo with the segmentation process, and then once the segmentation is done, now we have to perform this character recognition, optical character recognition, pick up individual character, and either you have to perform a translation or you have to perform a transliteration. So these are the two different options where we have with OCR, especially as the name itself indicates, you are going to recognize the characters. So once a proper OCR is been built, it's not done yet. This is where the actual challenge starts. Many OCRs or the character recognitions tool which we have today, their accuracy may be around 60% to 80%, with most of wrong interpretations. How are we going to rectify those wrong interpretations? So now we have a large language modules for that, which can help us. Whatever that I'm saying is not so easy that what I'm delivering now. We have a lot of hurdles and the challenges, but despite, we have that ray of hope where the large language models can be used to correct these misinterpretations. Maybe probably the word is not appropriately placed, or the meaning of that particular sentence is not appropriate, or the particular character which has been transliterated is not been identified properly by the character recognition. So these are all the different challenges which we generally see when we perform OCR. So probably the biggest advantage today, as we are in the artificial intelligence era, so where we can make use of LLM models. So with the help of large language models, we will be able to restructure and reconstruct so that the actual meaning or the gist of the content, whatever that is there on the script, will not be lost. So I'll be taking through the complete details of it, as a script processing has three major stages. One is data acquisition, then the second one is the data pre-processing stage, and then we have OCR, optical character recognition, and then we will be using language modeling for understanding and interpreting the proper scripts in a proper way. So the first step, whatever that I had discussed, is the pre-processing stage. Before that, this is an example which shows, it's a small script which I have taken from the internet source to show what exactly an image binarization is. That's the first original image which I have obtained, and that image is being converted into a grayscale. So that the first thing that what we have is any image which we have captured is in an RGB format. So that RGB format has to be converted into a grayscale. So it is not essential, but it is always good that you convert that into a grayscale image. So grayscale image is like a black and white shade between some values like 0 to 255. So once the image is in two color format, now it becomes for me to identify what is my background and what is my foreground. So if you look at the second image, I have a crystal clear that there is a background and there is a foreground. The foreground is my text and the background is the gray pattern. So now I have to only identify the text part which is there and removing all the background elements, so that those background elements could lead for misinterpretation of interpretation of OCR. So once we have converted that into a grayscale, now it's time to remove background. So we will isolate the text part from the isolation, and where your binarized image, so that's the last portion, whatever that we see is a binarized image. Once this binarized image is done, now we are ready for the segmentation. But before that, I would like to tell you how are we going to remove this isolation, how are we going to remove the background for this. Do we have any AI techniques for that, or any algorithms we have? Of course, definitely we have. As a conventional part, we have, how do we remove the noise? As I said, noise is an unwanted pixel that is present in an image. So how do we remove it first of all? So we have a conventional image processing techniques like filters. With the help of the filters, we will be able to remove unwanted pixels. Unwanted pixels is which is not required for me for identifying any scripts. It's not necessary for it. So such kind of pixels has to be removed. So we have a lot of filters to that. Apart from that, we have a artificial intelligence algorithm called as auto encoder and denoising technique. So this is actually in trending, which can be used for ancient script processing, especially to perform two operations. One is to remove the noise, the unwanted thing. Say for example, there is some stain on the palm leaf. I want to remove that stains on it. So probably if you can use the auto encoder technique and the denoising technique, I think it is the most efficient. So far, that is the technique which has been identified with good accuracy to generate the originality, removing all the unwanted pixels. So what exactly it does is, if you look at the first image, it takes the original images, whatever the images that we wanted to train our model, takes it, purposefully creates a noise to it. It gives more, introduces more noise into it, adds unwanted pixel purposefully, and then it starts training it. So in the process of encoder, what encoder does is, it is going to downsample the images by extracting the features. Whatever the necessary features that we have, those features are extracted by downsampling. That means the quality of the image is purposefully reduced by extracting the features. So once this autoencoder performs by extracting the feature, so autoencoder holds these important features. It holds the features which it has extracted and gives this downsampled image for denoising. So if you can see that, the first image, whatever that is, it is an example for the original images. Just for an instance, I have brought this image. And the second one is purposefully those noises are introduced. Why do we have to? Because my script is already been have a lot of noise. Why should I do it again? See, the beauty of machine learning algorithm is you make a mistakes and you try to understand from the mistakes. So you introduce more number of noise into it and try to rectify from those noise. That is what denoising actually does. What denoising does is it actually tries to extract the feature is already been stored and starts upsampling. It is going to reconstruct based on the features which is being stored by the autoencoder. Autoencoder already has downsampled it, and this downsampled image is actually given to the denoising technique. Denoising starts reconstructing the image based on the feature that is being given. So that whenever it restructure is done not based on the original image, based on the features that is being stored. Once it is being stored, so you can see that maybe if you look at the original image or the reconstructed image still has that ambiguity in representing the characters. But the reason why it is being done is, say let's consider we have trained around 1 lakh of data set. And now there is one more new data set which is being available, and I have given to my machine learning model for that. So when I give it to my machine model, so now the new data set which I have given for training, which were not as a part of a training, now will be able to recognize the characters. Because I'm trying to learn from the past mistake. My new image, whatever that I have given, is not a trained one. So might have more number of noises. So with the existing training model, whatever that exists, by my denoising will be able to identify the features and tries to reconstruct it. It's not going to compare with the first one, rather it is going to try to reconstruct with the features being stored. So that is where pre-processing will help us to remove the unwanted pixel and tries to reconstruct it. So once it's been done, the next stage is image binarization. Towards the left side, that is the traditional image processing techniques, whatever that we have. So we have R2 thresholding. That's a beautiful technique for thresholding. Thresholding in the sense, you are going to convert an image into 2 colors. It's a black and white. Black and white is not the black and white. So here the second one, whatever that we see is not the black and white. That's a grayscale. The last image, whatever that we see, is a 2-color format. The 2-color format is what we call it as a binarized image. It's a 2-color. Either it is black and white, or some people also use the amber color. But for OCR, it is always better to use a 2-color format. So that's why we call it as a binarized image. An image is represented only with the 2-color format. If you look at this image, the background is represented with white and the text part is replaced with the black pixel. So now it is very easy for me to further process and identify which character is what and what is the meaning of it. So we have these traditional methods, but we have a lot of AI methods which are parallel to it. So one of the beautiful AI-based method which we use is UNet method, a U-shaped fully convolutional neural network architecture what we use, which is very, very helpful for identifying or converting an image, a grayscale image, into a binarized image. So what exactly it's going to do? I mean, we have pix-to-pix and deep noising autoencoders, but especially for ancient scripts, so far in terms of its accuracy, there are few papers which have referred that UNet seems to be a promising binarization AI technique. So how does exactly it works? Now you can see that's a grayscale image, and where the grayscale image is being now converted into a binarized image. So what we do is, again, UNet also follows the principle of autoencoder and denoising technique. But here there is one more additional operation where UNet performs. Same thing. With respect to encoder, it downsamples, storing the features, and then all these features are being stored in a bottleneck, and there is something called as a skip connection. It makes use of a skip connection, where the skip connection will take the help of all the features that are there which has been encoded, and then tries to reconstruct the image. It's a very similar kind of what autoencoder does. It also does the same thing, but only one thing that what it does is there is something called as a pixel based classification. Once everything is done, it takes every pixel and decides whether that pixel has to be in the white color or the pixel has to be in the black color. So you can mask either with the black and white or with white and black. So two options are also there. I will show you what is that masking options. So this is how you get a grayscale into a image binary. So we have only two color formats. So unit works on pixels. Whenever any algorithm works based on the pixels, we will be able to control it and decide whether this pixel has to be in which color format, whether it can be in one color or a two color, whether I can retain that particular pixel or not. Based on that, unit actually is a very good image binarization technique which we can use it for. And once the image is being binarized, so now the segmentation comes into the picture. So there are a lot of segmentations techniques which are available. What is this segmentation? Segmentation is basically when I have a script, it divides that into number of lines. And again, with respect to an individual lines, every line is further divided into words. Again, those words are further divided into characters and then constructs a box to it. If it constructs a box to it, so I will be able to understand what is that particular character. So this technique is called as a image segmentation. An image has to be, with the help of an image binarization, we are supposed to identify the line, and within every line we have to again identify what is that word, and for every word we have to find out what is that particular character. So then apply the boxes to it. So one of the conventional method, I don't want to get in, there is a AI technique called as a YOLO technique. So, but connected component analysis is one of the good technique which can help us to create those boundaries. So I'll just show you how it looks like. There is So this is a tool which is used for creating the, recognizing the character. So what I have done is, so this is a script of a Brahmi Lipi. So here the text is taken from the various sources and it is being reconstructed digitally. This is a binarized image. So what I have done is, I have created a boxes. If you can see here, there is a box. For every character, there is a box. For each and every character, I have created a box and I have mapped what is this character, and that character is equivalent to what is the Kannada character that we have. So if we can properly create the boxes, then it becomes a mapping of every character, whatever that we have, and how you can transliterate to today's language will become very, very easy. This is a manual process, but apart from that, if I use automation tool, so I have something called as a connected component analysis. So what connected component analysis does is, we have the binarized image, then identifies every row. Once the row is identified, then takes the blocks and the blacks that are there in every pixel, identify how many number of black pixels are there. Based on the number of black pixels, it starts drawing the boundaries to it. The boundaries are being drawn for each and every character based on the number of black pixels that are being available. So you can see here, and every block, whatever that the black that you can see, that the block that's been identified in the green color is identified as an object. That means we are trying to cut a cake into small pieces and identify those small pieces as a character and give a character to it. So this is where your OCR, optical character recognition, actually comes into the picture. We have inbuilt optical character recognitions which are available. So the famous OCR which we use is the Tesseract, which works with LSTM RNN technique. So everybody knows it. But LSTM RNN technique is very good suited for predefined fonts. It's not so good for recognizing handwritten scripts, or even in case if you try to train a Tesseract with the handwritten characters. So it's a time consuming process and its efficiency is not so great. But now we have one more algorithm or one more tool called as a Kraken. You can see that Kraken. So Kraken is one of the OCR which works on LSTM convolutional neural network. So that particular tool, which is all these tools, whatever that I have displayed is an open source applications. So Kraken can be used for ancient script processing, especially for recognizing the text part. So I think we haven't, even I am also trying with the Kraken part. So I have actually used the Tesseract, and yes, we can get a good result, but now there is an opportunity where we can use one more model called as a Kraken OCR. It is also an open source, especially used for ancient script processing. So that's a beautiful model which can be used for OCR. What exactly a OCR does? How a character is being recognized, and how are we going to use the artificial intelligence for recognizing it? So the first thing is, once the segmentation is done, that means we already have those boxes. Every box is being created for every character. So once it's been done, see, Tesseract does all the things automatically. We do not have to do everything. Tesseract does everything, but I am giving you the gist of every steps, how AI can be deployed to get a better option, or what are the different models that we have, so that we can inculcate those models so that we can improve our character recognition and make the character recognition better. So as far as that, OCR first, once we have the segmentation, first identify the appropriate edges, vertical edges, horizontal edges, and also find the bends and the curves that is present in the loop. So once we have that, then identify the exact stroke. So these are the three things what OCR does before it recognizes. Identify the best stroke, best curves, best edges. So once it identifies a pixel based high level shape, then every high level shape is mapped with a predefined text, whatever that we are using today, right? So once we have those high level shapes, once those high level shapes are recognized, and once we start mapping with those characters, now my OCR starts working or recognizing the characters. So what exactly it does is, so now based on the boxes, so the every character is being mapped with the current character. This is for translation or for the transliteration. Whatever that I am explaining is with related to the transliteration, not with related to the translation. Where, say, let's consider there is a character A in the Brahmi Lipi. What is the equivalent character that we have in the Kannada? So that can, at least you can transliterate here. So once that's been done, mapping is done. So based on the pixels that we have already mapped, now based on the characters that is being mapped, now my OCR starts identifying what is the exact character for it. So now I have a pixel, based on the boxed pixel, what is that character and what is the equivalent character which I have mapped with. So now my OCR starts recognizing my the mapped character and the pixel character. So every character is being actually extracted line by line. So it depends upon the type of algorithm. So now every character is identified. Once the character is identified, as I said in the initial stage, OCR many number of times might not interpret the right answers. It might not give you a correct answers, or OCR wouldn't be so accurate to give you the research. What is the other option that we have? We have large language modules which can be used. So we have a transformers which we can use. So one of the transformer for an ancient script processing which we can use is a byte-to-byte T5 model. So this is one of the byte-to-byte. Again, this model, whatever that I have chosen, is for transliteration. It is not for the translation. What it actually does is finds if any glyphs are missing based on the OCR what it has performed. Any of the characters being given is not properly being shown, or it is misinterpreted. Say, let us consider, rather than showing it as ga, it has showing it as ka. So my transformer model has to identify based on the context. What is the proper context? And can I improve this context, and whether this is actually giving a proper meaning for it. So we use NLP model for it, natural language processing model. So one of the NLP model what we can use is byte to byte T5 model. So this is actually a good one, where I have started working on these models for rectifying transliteration process, not for the translation process. So once the script is being processed, so there is always a challenges. What are those challenges which we have? Do we really have so accurate models where we can get an end-to-end solution? Despite of all these methods that we have, still we have the limitations. Before that, so one of the limitation is, as we were discussing initially, corpus. Most of the people, I mean, I was talking with Uday Kumar sir in this morning. He was saying that everybody is working like a single elephant. So we have the data set, but we need the people who can work in a larger scale. So one thing is, collecting the corpus is very, very important. If the corpus is not sufficient and the corpus, your data set is very, very less, despite you train any model, the accuracy of the model is not so great. It's very, very restricted. I mean, you cannot get the actual answer what you are actually expecting for. So the data collection is very, very important. So once you have a proper data set, then you can start training your model. And then complexity of the scripts. So as we know, there are a lot of intricacy with respect to the text that are being inscribed. So we should understand, we should properly pre-process what exactly the context is. And once a script complexity is understood, then it's not so easy again. We need the experts. As a person who knows the technology cannot do everything. He is the one who is on the other side. He cannot, and if he doesn't understand what the exact script is, it's very, very difficult. It's very important that collaboration from various people from the various backgrounds are required. Collaboratively, they have to come and work to give the proper model. Maybe research institutions, maybe a government organization, maybe some autonomous organization, and the academic institutions. I have heard a couple of education institutions been seriously working on OCR recently. Probably I think if everybody of us, whoever is there, whoever is interested in building our own script processing, at least for a Kannada language, it will be a great output for the Kannada literature. So these are the limitations what we have. And apart from that, these are the actual AI models which we have today. One of the AI model which is in boom and which is making noise in terms of OCR is the last one, which is Mistral OCR. So Mistral OCR, people have started taking it and understanding and started training on ancient script. So compared to the Google and the Azure, there are other transformers which can perform a better OCR, but so far the Mistral is one of the OCR which has been providing a good output as a ancient script processing, but so far the Kannada processing, script processing is not been done with the help of Mistral OCR. So it's a high time for each of us, whoever is interested can join the hands to come up with such kind of a model. And before I wind up, I would like to show the process of there is a small application which I have built for just to demonstrate what exactly image is, how it can be converted into a binarized image, and how it can be converted into how boxes are being applied. I just would like to show the demonstration of it. Whatever the models which I have told now, I have used autoencoder here, and I have also used a small segmentation technique for binarizing the image. So here, so this is my original image which I have taken. I think this image seems to be better, but this is an example to show how a binarized image is created. And with the help of the binarized image, how are we going to construct those boundary boxes? So here I have a thresholding where I can just move on. Now you can see that this particular image is now converted into a binarized image. For the binarized image, for every character you can see those boundary boxes. Based on these boundaries, if we are able to construct these boundary boxes, so it will be very helpful for mapping the characters. It becomes very easier. But mapping these boundaries would always be a challenging factor, and converting into a binarized image is always a subjective. Whatever the OCR techniques that I have said is always a subjective. See, the techniques adopted for the inscriptions which are there on the stone wouldn't be the same, especially for pre-processing stages, wouldn't be the same that what we can use the method for pre-processing a palm leaf. The technique depends upon the kind of the inscription or the kind of the material that's been there. But once we have an appropriate text which is a proper pre-process, then it's very easy for us to get. So this is on handwritten characters. Now you can see that here you have a handwritten when being converted into a binarized. For every character, you can see the boxes are being bounded to it. Once it's been done, we have the OCR which is trying to recognize those characters. So as I increase the thresholding, so this is a controlled based thresholding. So if I increase it, you can also see here there is a misinterpretation of the characters which is happening here. So it depends upon what is your kind of a document which you are using. So there is one more example which I would like to show you and then wind up my talk. A small Kannada script which I have taken. I think I have to change a bit of code here. Here I have used Tesseract itself. You can see the challenges. See, despite if the scripts are not been properly processed, now you can see even the text recognition is also not done properly here. So to properly interpret, definitely large language models will help us. Again, for that we need large data set. But prior to this, if we can properly make a proper image binarization technique and a segmentation technique, that would be a great thing for OCR, irrespective of whatever the LLM model that we can use. So as I think you can read whatever it is there, and it's OCR part, which is a text editing where I can edit this further and where I can recorrect it. So thank you so much.